Hey everyone, and welcome. Today, we're going to be talking about a seriously powerful tool in your trigonometry toolkit, the law of cosines. I'm telling you, if you've ever been totally stuck on a triangle problem, this might just be the secret weapon you've been looking for.
So let's just jump right in with a question. You've gotten pretty good with the law of sines, right? You're solving triangles left and right, everything's going great, and then bam, you hit a wall. You've got a triangle in front of you, but for some reason, the law of sines is totally useless. Now what?
Well, that wall, that roadblock, it's got a name. Side angle side, or SAS for short. This is that really specific case where you know two sides of a triangle and you know the angle that's wedged right between them. And this is the exact spot where our old friend the law of sines just can't help us.
And here's exactly why. To get the law of sines to work, you absolutely need a complete pair. You need a known angle and its opposite known side, like you see on the left with angle-angle side. That pair lets you build your ratio. But now look at the SAS triangle on the right. See the problem? The angle we know is trapped between the two sides we know. We don't have that crucial opposite side. We're stuck. Or are we?
And this is where our hero arrives on the scene. When you hit that SAS roadblock, it doesn't mean the problem is impossible. It just means you need a different tool. And that tool, my friends, is the law of cosines. It is literally designed for this exact situation.
Here it is, in all its glory. Now I know, it might look a little intense at first, but the logic here is just beautiful. It lets you find any side, let's call it side C, as long as you know the other two sides, A and B. And the angle that's directly opposite C, we'll call that angle C. The one thing you have to burn into your brain is this. The side on the left of the equation is always opposite the angle you plug into the cosine on the right.
Okay, and here is the aha moment. This is the part that connects this brand new formula to something you've known for years. Think about it. What happens if our triangle is a right triangle? Well, angle C would be 90 degrees, right? And what's the cosine of 90 degrees? It's 0. That means that whole last chunk of the formula, the minus 2ab cos of c, just poof, it becomes 0 and vanishes. And what are you left with? C squared equals a squared plus b squared, the Pythagorean theorem. So you see, the law of cosines isn't some strange, complicated new thing. It's just a superpowered version of a formula you already know and trust.
All right, enough theory. The best way to really get this stuff is to see it in action. Let's get our hands dirty and solve a couple of triangles. We'll go step by step. Okay, let's kick things off with a classic SAS problem. We've got side A is 8, side B is 11, and the angle C between them is 37 degrees. Step 1, we just write down our formula. Step 2, we plug in all the numbers we know. Step 3, and be careful here, we just run the calculation. Remember your order of operations. We get that c squared is about 44.44. And for the final step, we take the square root of that, which gives us our missing side, about 6.67. See? Not so bad, right? A clear path straight to the answer.
Okay, so you found one missing side. That's awesome. But what if you need to solve the entire triangle? I mean, find all the missing sides and all the missing angles. You ready? Let's level up.
Let's check out a full example. Here we've got side B is 15, side C is 20, and the angle between them, angle A, is 55 degrees. So our first mission is to find the side opposite that angle, side A. We just use the version of the formula that solves for A, plug in our numbers, run the calculation, and we find that side A is about 16.74.
And here's the key strategy, the really smart move. The law of cosines does the heavy lifting for us. It basically unlocks the triangle. By finding side A, we now have a complete angle-side pair, angle A and side A. And what does that mean? It means we can now switch back to our old friend, the law of sines, which is usually way faster for finding the other angles.
So for step 2, we just set up our simple law of sines ratio to find angle B, which turns out to be about 47.3 degrees. And step 3, it's the easiest part of the whole problem. We all know the angles in a triangle add up to 180, so we just subtract the two angles we now know from 180, and that gives us angle C, 77.7 degrees. And just like that, the entire triangle is solved.
Now, before we wrap this up, I've got a pro tip for you. There's one really common mistake that trips up so many people when they're first learning this. I want to make sure you don't fall for it. I call it the obtuse angle trap.
So here's the deal. You have to watch out for this. If your angle is obtuse, bigger than 90 degrees, its cosine is going to be a negative number. And this is a huge deal because remember the formula? You're subtracting that whole last term. So when you subtract a negative, it flips the sign and becomes addition.
Just look at this side by side. With our first acute angle, 37 degrees, the cosine was positive, so we subtracted and got a side length of about 6.67. But look what happens with an obtuse angle, like 120 degrees. The cosine is negative, 0.5, so that minus sign in the formula crashes into the negative from the cosine, turning the whole thing into addition. And that gives us a much longer third side, which makes perfect sense, right? A wide angle should create a long opposite side.
So you might be thinking, okay, this is great for my math test, but when am I ever actually going to use this? Well, let's take a look at a real-world example where this formula is absolutely critical.
Picture this. You're a pilot. Your instruments tell you your distance to two different navigation points on the ground, two waypoints. You also know the angle between the flight paths to get to them. What do you have? You have a side, an angle, and another side. A classic SAS setup. Using the law of cosines, you can instantly calculate the direct, straight-line distance between those 2 points. That's vital information for planning your route and managing your fuel.
So, there you have it. You've seen how the law of cosines lets you find any missing side of a triangle when you're stuck in an SAS situation. That's a huge step. But it leaves us with one last pretty interesting question. What if you know all 3 sides of a triangle, but you don't know any of the angles? Could this same formula help you then? Well, that's what we'll explore next time.